everyone. So today here we are going to have the definition of the derivative. As you mentioned, I remember last time I gave you f prime of a, right? It will be limit h close to 0, f a plus h minus f of a over h, right? So here we have limit h close to 0, f a plus h minus f of a over h. And we mentioned that that's one formula here. That's equation number 1. Equation number 2, limit h close to 0, f of b. That's another formula here. I gave it to you last time. F of b of a, it will be f of b minus f of a over b minus a, over b minus a. That is two equation here. We would like to apply these two equation here. How to apply? I mentioned the equation 1 and 2. That is, it will be kind of the slope of your f of x at x equal a, right? And number 2, I mentioned also that is the slope of the tangent line, right? Tangent line at x equal a, right? And then I mentioned to you also that is number 3, we call it here instantaneous rate of change, instantaneous rate rate of change of your f of x, change of f of x at also x equal a, right? So we have the slope. And number 4 here we mentioned the derivative, that is called the derivative of f of x at x equal a, the derivative of f of x at x equal a. And the derivative here, we call it here sometimes f prime of x, or sometimes we write df by dx, the derivative of f with respect to x, where f here is a function in x. Your f is a function in x, and that is the reason you have to take the derivative with respect to x. So today here we are going to show you how to use equation 1 and 2 just for the derivative for number 4 here for the derivative. So let me give you example here so that you can have feeling about this, how to apply this definition, either number 1 or number 2. If you have f of x equal here negative x minus x squared, what is the question here? The question here, they ask you use the definition of the derivative. I have to use the definition of the derivative, that is the question here of the derivative, right? So use the definition of the derivative to compute here f prime of a f of x algebraically here. So that is what they mention algebraically, which means are going to use. And then they are asking you use part A. I have to use part A to compute f prime of 0, to compute f prime of 0. Okay, so let me show you how to do this one here using equation, maybe equation number 1, and then we'll use equation number 2. So, and then it's up to you, can use 1 or 2. The equation 1, we call it the definition of the derivative. Equation 2, also the definition of the derivative. So let me show you here. Let us use equation number 1. So I need to get f prime of a when x equal a, f prime of x here, this one here, when x equal a. So it will be limit h close to 0, f a plus h minus f of a over h, right? That is the equation I'm going to use. And they mentioned here I have to use algebraically. Algebraically means you have to compute this fraction here as much as you can and simplify as much as you can, and then at the end you replace h by 0. All right, so what is your f of x? Your f of x is given negative x minus x squared, right? Negative x minus x squared. So here f prime of x, if you want, you can write here x. It will be here x, and then you have here x, right? It will be the same here, x, and here it will be x. So it will be f prime of x limit h close to 0, fx plus h minus f of x over. So that is f of x is given. I need to compute f of x plus h. What is how to compute f of x plus h? So that is your x here. Look what you have. I put circle around x. So here x plus h means you replace x by x plus h. Whenever you have x, just take x out and put x plus h. So what do you have? You have negative x plus h. I put it in circle here. That is x plus h. And then minus x plus h. The whole thing is here is square. So I replace what I did here. I replace in 1. Replace in 1. All right. In equation 1. Replace in 1. That is what I have. Replace 1 x in 1 x by x plus h. So whenever you have x, just take it out and put here x plus h. All right. So now I need to simplify f of x plus h here. So negative multiplied by x, you get negative x. Negative multiplied by h, you get negative h. Right. Here you have x plus h squared. What is that? It's a bracket multiplied by itself twice. So if I open bracket here, x plus h squared, it will be x multiplied by h, which is x squared plus 2xh plus h squared. Right? So that is come from here, x plus h squared. It will be x plus h multiplied by x plus h. And then expand the two bracket here. It will be x squared plus 2xh plus h squared. That's what you have there. If I simplify, you have negative x minus x squared minus 2xh minus h squared. I'm just expanding. Then I go back to here. That is equation number 1 here. That is I'm going to use. So here, let me give you hint. What is the hint? F of x. F of x, always your f of x is going to be deleted with some term with f of x plus h. Let me show you. Right? So your f prime of x here, the derivative at x, it will be limit, right? H close to 0. What is it? Your fx plus h minus f of x. The whole thing divided by h. So here that is f of x plus h. I copy this between big bracket. So it will be limit h close to 0. What is f of x plus h? Here I just copy from there. Open big bracket, negative x minus h minus x squared minus 2xh minus h squared. So what this one here? That is your f of x plus h minus another bracket f of x. What is f of x come from? That is what is given equation number 1, which is negative x minus x squared. Negative x minus x squared. The whole thing divided by h. The whole thing divided by h. I told you this. That is your f of x. Your f of x somehow is going to cancel with f of x plus h. Look what you have. Negative x here cancel with negative x because you have in the middle minus. Negative x squared. Where is negative x squared? Negative x squared. So negative x squared minus negative x squared, they cancel each other. So what do you have left? Negative h from here, negative 2xh minus h squared over h. Right? So the first hint I mentioned to you here is, I told you f of x in this equation is going to cancel somehow with the other term. What is another hint I should give it to you? You have h. H close to 0. So we cannot divide by h. We cannot divide by 0, which means your h here you should somehow get this term that what you have, whatever you have up here, you should get h. You should get h. So if I simplify this, it will be limit h close to 0. Go ahead and factor h. If I take h out from the first term, you have negative 1. If I take h out from here, you have negative 2x. If I take h from here, you have negative h. The whole thing divided by h. Right? So h here cancel with h. All of this before I take the limit, because I try to simplify as much as we can. So now if I take limit h close to 0 and then negative 1, negative 2x minus h. So how to take the limit? It's a constant. X here is real numbers. 1 negative, h here close to 0. So h close to 0 means the whole term, just replace h by 0. Replace h by 0. So you have negative 1. That's a limit of any constant should be the same constant. Limit of any constant should be constant. Negative 2x, what is x? Is a number. So it will be the same also constant. I should write it. just I replace h by 0, then this term becomes 0. So that is our derivative. That is our derivative, where I use this derivative by using the derivative by replace x by that's f prime of x. All right. So here, if I go to back here, what do you tell you? Use the definition of the derivative to compute f prime of x algebraically. That's what we did. We simplify as much as we can. At the end, you take h close to 0. So what is part B? Use part A to compute f prime of 0. F prime of 0, what is your x? Where is your x here? X equal 0. X equal 0. So I have to figure out f prime of 0, which means just replace x by 0. Replace x by 0, that is your x. If I replace x by 0 here, you get -1. You get -1. All right. So that is equation number 1. How I'm going to use equation number 2. Equation number 2, in order to make it easy and clear, I need to figure out, so what is equation number 2? F prime of A, right? It will be limit B very close to A, f of B minus f of A, the whole thing over B minus A, right? So that is the formula. Let me show you how to use this one. And then it's up to you at the end. You can use equation 1 or this equation number 2, either or. Now I need to get f of b. What is your f of x given? F of x given negative x minus x squared. What is your f of a? Just replace x by a. Replace x by a. So you have negative a minus b squared. Minus a squared. Right? I'm just replace x by a. Just replace x by a. What is f of b? Just replace x by b. So you have negative b minus b squared. So here I replace x by a. Right? And here I replace x by b, just b, and here x by a, right? So now I go back to this equation. That is what? That is your average rate of change, of your f of x, right? So what I'll do, I take this average rate of change, I simplify as much as we can. At the end, I will take the limit. What is the limit? B close to a. B close to a means you replace b by a. Replace b by a. So what is the f of b? So here f prime of a, it will be limit, right? It will be limit, right? B close to a. What is f of b? Just f of b, just copy f of b. It will be open big bracket. Your b is f of b negative b minus b squared. That is your f of b. Close the bracket minus f of a, which is negative a minus a squared. All right, the whole thing divided by b minus a. All right, let me give you a hint. What is the hint here? You said, we mentioned here is given b close to a. B close to a. So what is b minus a? B minus a close to what? If you have b close to a, then this one close to a, so you have almost a minus a, which is this one close to 0. So here we cannot divide by 0. Can we divide by 0? No. So which means your derivative, your hint here is your f prime of a. It will be limit b close to a. Somehow I must, as you have b minus a, which is 0 here, and we cannot divide by 0, this one somehow I must get b minus a multiplied by something. I must get up b minus a so that I can cancel those together, and in the bracket here something, and whatever left here, that is the one I'm going to replace b by a. Why I'm doing this? Because b close to a means b minus a is almost 0, and we cannot divide by 0, right? So how to simplify this? How to simplify this one here? Just let us collect the linear term here, negative b, right? Negative b minus a. So look what you have here. There is negative sign here. So if I simplify this, negative b minus b squared minus negative times negative, you get positive a. Negative times negative a squared, you have plus a squared. The whole thing over b minus a, right? So now I'm going to collect the linear term. That's linear term, and that's linear term. So what do you have? You have limit b close to a, right? So negative b plus a, right? Negative b plus a, and here you will have a squared minus b squared. A squared here, right, with minus b squared. The whole thing over b minus a, right? So now what do you have here? Limit. If I take negative sign here from here, if I negative factor out those together between bracket here, if I put the first two term between bracket, the last two term between bracket, so what do you have? Limit b close to a. If I factor negative sign from here, you have b. If I take negative b out, you have ab. What is you have? You have plus. If I take negative out of plus, what do you have? You have negative a. From here, what do you have? You will have a square. A square. I can factor this as a minus b multiplied by a plus b. Right? I can factor this a minus b multiplied by a minus b. Right? So if you want, I could do this one here like this too. And what you have? What do you have here? A minus b. Right? A minus b. A first and then minus b. And then the whole thing divided by b minus a. So now if you look to what you have here, a minus b, and here also a minus b. Right? So now what happens if I factor out a minus b out? If I take a minus b out from here, what do you have inside? From this, what do you have left? You have 1. If I take this one here, the whole thing out, you have only 1 left. Plus, if I take this one here out, what do you have left? A plus b. A plus b. And here, this one that you have b minus a. B minus a, right? So that is limit b close to a, and that is f prime of a, right? So now let me ask you, what is the relation between a minus b and b minus a? What is the relation between, I'm asking you, what is a minus b? This one, what is the relation between a minus b and a minus? Is there any relation? Yes. What is the relation? If I have negative sign here, if I factor out negative sign, look what you have. Negative multiplied by b, you get negative b. Negative times negative, you get positive. So the difference between those two guys, it's only negative sign. So the difference between this term and this term, it's only negative 1. This term, when they cancel, look what you have. A minus b. If I factor out negative out, so what do you have left? B. From here, what do you have? You have plus a, which means I get negative sign. So negative times negative, you get positive. So if I expand the bracket, you get exactly a minus b. So those two here means when I cancel those together, then you get negative 1, because the difference between those two guys, only negative 1. So what do you have? F prime, the conclusion f prime of a, it will be limit b close to a, and from there you have negative 1 up here, negative 1 multiplied by 1 plus a plus b, close the bracket, right? So now what do you have? What did you got here? Negative 1 plus a plus b. I'm going to replace b by a. When you say b very close to a, means you replace b by a. Replace b here by a. If I replace b by a, what did you get? Your f prime of a, it will be just negative 1. Just write negative 1 here, negative 1, and then whenever you have b, just leave everything exactly the same except replace b by a. So what do you have? You have 1. That is your a. I leave it as it is. Just replace b by a. So what do you have? You have a. So what do you have here? You have negative 1 multiplied by 1 plus 2a. Negative 1 plus 2a. And that is your f prime of a. And that is exactly, that's what I got up here. If you look to for the first technique here, where the second one here, it's negative 1 minus 2x. I replace x by a. So it's exactly the same like this one here. Look what you have. What is the question? The question here asks you to f prime of 0. So f prime of 0, just replace a by 0. And then if you replace a by 0, what did you get? You get negative 1. If I replace a by 0, you get negative 1, and that is also our derivative. So here, if you like this equation number 2, you can use it. If you like equation number 1, you can also use it. So either or, that is called algebraically here. The reason we call it algebraically, because before I take the limit, I leave the limit up to the end. Just I simplify as much as we can. At the end, we took the limit. Okay, so that is what I have there. So now I need to give you here another example, and then I give you what is the numerical way. So example number 2 here, if I give you f of x equal x cubed plus 2x. X cubed plus 2x. What is the question here? Then use the definition of the derivative. We have to use the definition of the derivative, right? The definition of the derivative, right? Here to what? Use the definition of the derivative to compute or to find f prime of 2. F prime of 2. So what is your a here? F prime of 2 means your a here, your a is 2, your x here is what? Is 2. Your x equal 2 and your a here also is 2. So now let me use equation number 1. So f prime of 2, it will be limit h close to 0, f of 2 plus h minus f of 2, the whole thing divided by h, right? So now what is your f of x? Your f of x here is given x cubed plus 2x. So now what is f of 2? Just replace x by 2. So what do you have? X by 2 here, that is your x, that is my x. Whenever you have x, just replace it by 2. You get here 8 plus 4, which is 12. 12, that is f of 2. That is what I need here, is 12. Now what is f of 2 plus h? F of 2 plus h, I need to compute that. Then you replace x by 2 plus h. Replace x by 2 plus h. So just let me write it. Replace x by 2 plus h. Right? You have to replace x by 2 plus h. Then what do you have? You have 2 plus h cubed plus 2 and 2 plus h. Right? If I simplify this, you have that. What's the meaning of this? It's 2 plus h multiplied by itself 2 plus h multiplied by itself 2 plus h. It's a bracket multiplied by itself how many times? 3 times. And then if I simplify this, 2 multiplied by 2 you get 4, 2 multiplied by h you get 2h. And now I have to simplify this one here. I take the first two bracket, any two bracket, take the first two or last two, the same. So 2 multiplied by h you get 4 plus 4h plus h square. That's the first two bracket when I expand them. Multiply by 2 plus h, that is equal 4 plus 2h, right? So now I have to expand this one. So 4 multiplied by 2, you get 8. 4 multiplied by h, you get 4h. 4h multiplied by 2, you get 8h. 4h multiplied by h, you get 4h square, right? h square multiplied by 2, you get 2h square. h square multiplied by h, you get h cubed. That is the bracket here to the power 3, and here you have 4 plus 2h. So now 8 with 4, what do you have? You just combine them, you get 12. 8 with 4, 12 plus 4h. 4h with 8h, 12h, and here you have 2h. So 12 plus 2, you get 14h, right? 4h square here, this one here, this one 3 here. 2h square with 4h, you get 6h square, and you have h cubed. You have to be quite careful here when you simplify. So I got this one. So now I go back to the equation. What is the equation here? The equation f prime of 2, it will be limit h close to 0, f of 2 plus h minus f of 2, the whole thing over h. So now what is f of 2 plus h? Just both big bracket. So you have big bracket, just copy from here. That is f of 2 plus h. Let me give it a number. For this equation you have 12, right? Just number 5. 12 plus 14h plus 6h square plus h cubed. Close the bracket minus f of 2. What is f of 2? 12. The whole thing over h. If you recall, I mentioned to you a hint. F of 2 always cancel with some term. F of 2 here is what? 12. You have 12 here cancelled. So this term always cancel. Now you have h divided by h close to 0. We cannot divide by 0. Which means I have to simplify that before I take the limit. Take h up here. Take h up. So now what do you have left? You have 14. If I take h out of 14, what do you have? You have 14. You have here 6h square. If I take h, you get 6h. you have h cube. If I take h squared, what do you have? You have h squared, the whole thing over h. So now cancel h with h, right? So what do you have? Limit h close to 0, and you have here 14 plus 6h plus h squared, right? I factor out h from here. 12 cancel with 12. You have h from here, you get 14. If I take h, you get 6h. If you have h cube, you take h, you get h squared. You now just take the limit now, simplify as much as we can. We cannot simplify more. Then just replace h by 0. What do you have? You get 14. So h here 0, and then you have 0. What is left? Only 14. So that is your derivative at 2, and that is also your slope of your f of x at 2. All right. So that is this method here. We call it algebraically here. So we compute this derivative that will compute f prime of 2 algebraically. So now let me give you how to compute that numerically here. Numerically, how to do that numerically, because sometimes we ask a questions or your function here is very complicated. You have to do it numerically. So here f prime of 2, it will be limit h close to 0, f of 2 plus h minus f of 2 over h, right? H close to 0 here. So here, what is your f of x? Your f of x equal x cubed plus 2x, right? So what I'm going to do here, in order to do this numerically, I have to left limit and right limit. So what is the left limit and right limit? Your h close, your left limit, take h close to 0, left limit here, h close to 0 from the left, h close to 0 from the left, right? So if you take from the left, means you take h equal negative 0.0001, h close to 0 from the right, that is your right limit, then you will have h equal plus 0.0001. You have to do left limit and you have to do right limit. So that is this equation here. It will be just replace h by from the left and from the right. Then you have f prime of 2. It will be almost because I take the limit. It will be f of 2 negative 0.001 minus f of 2, the whole thing divided by h, which is negative 0.0001. That is my left limit. That is our left, right? Then if I try to finish the left, how did I get the left? Again, just go this in this equation here, just replace h by negative 0.001. Replace h here by negative 0.001. If I replace h by negative 0.001, the f of 2 will be the same, right? So you have to use technology. So what do you have? You have f 2 negative 0.001, you get 1.49 or 39, it's 49 here, minus f of 2 over negative 0.0001. What is your f of x? Your f of x equal x cubed plus 2x. So I have to go back to compute this one. So what is f of 1.999? It will be 1.999449, right? Plus 2, 1.99949. And f of 2, we mentioned, let's replace x by 2. So you have 2 cubed plus 2. And replace x by 2. What do you have? You have by 2 you get 2. So you have 8 plus 4, you get 12. So I have to use technology to compute this one. If I go back here up, that is almost f prime of 2, right? F prime of 2. So I have to go f prime of 2 here, just almost, it will be open big bracket, just copy from this, which is 1.99949 to the power 3 plus 2, 1.49, right? 49, 1.234, and then close the bracket, minus 12. The whole thing divided by negative 0.001. So negative 0.001, that is 30 here, right? 30, 0, 1, 2, 0. Then you have to use technology. You will get something close to 14. Something close to 14, almost 14. Try. Use your technology. You get 13.8 13, almost you get maybe 13.99, something like this, which is close to 14. You have to repeat the same story for the right derivative. How to compute the right derivative? Just I took h equal plus 0.0001 positive. Then what is your f prime of 2? F prime of 2, almost. This one mean limit or almost. What you have, f of 2 is h minus f of 2, the whole thing over h. So now if I take the right derivative, it will be f of 2 plus 0.001 minus f of 2, the whole thing over positive 0.001. Right? So this one here, it will be f of 2.001 minus f of 2, the whole thing over positive 0.001. Right? So what is your f of x? Your f of x here is x cubed plus 2x. So which means I need to compute f of 2. We said 2 cubed plus 2 multiplied by 2. So you have 14. You have 12. So you have 8 plus 4, you get 12. F of 2.0001, it will be 2.0001 cube plus 2.001. Now I go back here, that is your f prime of 2 from the right. If I do that here, it will be f prime of 2, it will be 2.0001, that is your f of 2 here, cube plus 2.001 minus 12, the whole thing over positive 0.001. If I use technology for this, it almost you get 14, which is you are going to get 14.00001 or something like this. All right, so that is your numerical way. As you can see, your left derivative equal 14 or almost 14, and your right derivative almost 14, and that is because of this. It's your derivative here, it will be 14. Your derivative here is 14, almost 14. Why? Because your left derivative, when I took h close to 0 from the left, I figure out your f, you get 13.999, which is almost 14. When you take it from the right, that's what you have here, then I go back here for a star, just to replace h by one time 0.001, that's give you right derivative, and another time you negative 0.001 to get the left derivative, and then you will have what's called here our derivative numerically. All right, so that is called numerical, how to get the derivative numerically, and also how to get the derivative algebraically. All right, so we could I have one problem I would like to give it to you, algebraically also and numerically. Maybe I ask you to try. If I have f of x, say equal 1 over x, just 1 over x, and now I need to find f prime of 1. So if I do that algebraically or numerically, how to do it numerically? F prime of 1, it will be limit h close to 0, f of 1 plus h minus f of 1 over h. What is your a, guys, here? What is your a? 1. So I replace f prime of 1, it will be limit h close to 0, f of 1 plus h minus f of 1 over h. Right? So if you would like to do it numerically, then what you should do, you are going to do left limit h close to 0 from the left, which is negative 0.0001, h close to 0 from the right, which is plus 0.0001. Then you have to, so you have here f of 1 negative 0.0001 minus f of 1 over negative 0.001, and here you have f1, right, plus 0.001, that's from the right, minus f of 1 over h, which is plus 0.001. Right? So now that is your left derivative, that is almost f prime of 1, and that is almost f prime of 1. So that is f449 minus f of 1 over negative 0.001. and this one it will be f of 1.001 minus f of 1 over plus 0.001. You have to use technology. Your f of x equal 1 over x, right? So which means your f of 1 is 1 over 1, which is 1. Now I need to compute this one. How to compute this? What is your f of 0.9949? It will be 1 over 0.999 like this, right? So if you go back here in this equation, it will be 1 over 1.999, right, minus 1 over what here? Over here, over h, which is negative 0.001. You have to use technology for this one here, guys. You have to use technology for this one, and you are going to get something close to negative 1. All right, you are going to get something close to negative 1. So you may get negative 1.0001 like this, and the other one, that is your left derivative. So your left derivative close to negative 1. Yeah, just go ahead and use technology for your left. That is your left derivative. All right, you have to repeat the same story, left derivative. I have to repeat the same story for the right derivative. What is your right derivative? Your right derivative. So what I have, it will be f prime of 1 almost 1.0001 minus f of 1 over positive 0.001. How did I get that? That is come if you look to up here that this part f 1.001 minus f of 1 over plus 0.001. That is when h close to 0 from the right. I replace h by 0.001. You get 1.001 minus f of 1 over this. So if I do that here, you will get, what is your f of x? Your f of x equal 1 over x. So what is f of 1.001? You just replace x by whatever you have here. So you have 1.0001, right? So this function here, or this ratio here, I have to compute this, right? So how to compute this, right? So let me show you here. All right, so here just okay. So yeah, f 1.001. So what is your right derivative? It will be f of 1 almost 1 over, that is, what is f, what this one here? It will be 1.001, right? So that is minus f of 1. F of 1 here is 1. F of 1 is 1, right? You get 1 over 1, which is 1. The whole thing divided by 0.0001. If I use technology for this, you will get again something close to negative 1. Negative 1 means you get negative 0.9, maybe negative 0.99999, something like this. All right, so you have negative 0.9999, and that is the one that you have for. So what is my derivative here? Your derivative here is almost negative 1. Your derivative here is almost negative 1 because your left derivative is negative 1 and your right derivative is negative 1, and then that is what I have for this one. So now I can use algebraic one, and I can algebraically. So how to use algebraically here? So for this one, it will be limit. So if I use f prime, what is the question here again? F of x equal 1 over x. So I give this one numerically 1 over x. I need to get f prime of 1. So f prime of 1, that is algebraically here. So let me show you how to do algebraically. Algebraically, what I did numerically, f prime of 1, limit h close to 0, f of 1 plus h minus f of 1 over h. Right? So what is your f of x? Algebraically means you take this fraction, you simplify as much as we can. At the end, you replace h by 0. F of x equal 1 over x. What is f of 1? F of 1 equal 1. All right. So what is f of 1 plus h? You have just replace x by 1 plus h. You replace x by 1 plus h. So what is this formula here? It will be limit h close to 0. What is f of 1 plus h? It will be 1 over 1 plus h minus 1 The whole thing divided by h. The whole thing divided by h, right? How to simplify this? That's called compound fraction. Compound fraction. So how to simplify? I can rewrite it as 1 over plus h like this, minus 1. And the whole thing divided by, I can divide it by h like this, divided by h like this. That is limit h close to 0, right? Divided by h like this. So now how to simplify this? All right, so this one here, you have 1. You have here 1 plus h. So I could write this as limit h close to 0. This one, it will be 1 plus h minus 1 plus h over 1 plus h. 1 plus h over 1 plus h, you get almost 1. So I wrote 1 plus h up and down just to get 1, right? So now I can combine those together. How to combine this? The whole thing divided by h. So 1 minus whatever you have up here. Here you have 1 plus h, you have here 1 plus h. So you have 1 minus 1 plus h over the whole thing 1 plus h, right? Because I can combine them now. The whole thing divided by h. The whole thing divided by h. So limit h close to 0. Then look what you have, 1 cancel with 1. 1 minus. So you have negative sign here, multiply h. So you have negative h over 1 plus h. The whole thing divided by h, right? Limit h close to 0. That is your f prime of 1. So now I have to recall what you have to recall. If you have a divided by b, the whole thing divided by c over d like this. If you try to switch division to product, then you have to flip this term. So you have d over c. This one, it will be d, instead of c over d, it will be d over c. That is, if you have division, you try to flip to product here. So this one division. So what do you have? Limit h close to 0, negative h, 1 plus h. H here is what? Is nothing but h over 1. H over 1. So now if I try to do product, it will be, instead of h over 1, it will be 1 over h. Flip. So it will be 1 over h. So now I can cancel h with 1 h here, right? So if I cancel h with 1 h, what did you get? That is f of 1. So it will be limit h close to 0. H cancel with h, you have negative sign. So you have negative 1 over 1 plus h. Negative 1, because h cancel with h, you have negative 1. And down here you have 1 plus h. Now when I take the limit, I can simplify more. No, that is the maximum I can simplify. When I take the limit, you have h close to 0, which means just to replace h by 0. Then what did you get? Get negative 1 over 1. Negative 1 over 1, because your h is 0. So that is your f prime of 1. Your derivative here is nothing but, is what? Is negative 1. Your derivative here is nothing but negative 1. So let me summarize this one here. This problem is really good, very interesting. Algebraically, what is your f of x? 1 over x. I replace x by f of 1, just to replace x by 1. 1 plus h means you replace x by 1 plus h. You have 1 over 1 plus h. So now this one it is nothing. This one it's f of 1 plus h. This one here f of 1 plus h minus f of 1 over h, right? Then I simplify, take whatever I have up divided by whatever I have down. Whatever I have up here, I have to simplify it. You can simplify it any way you like. You have, I figure out, you have 1, which is 1 plus h divided by 1 plus h. Then I can, whatever 1 plus h here, 1 plus h here, then I can combine whatever I have up. It will be 1 minus, open bracket, 1 plus h. Now I expand the bracket, negative 1 multiply by 1, you get 1, cancel with 1. Negative 1, negative multiply by h, you get negative h. That is divided by h. Now there is a rule. If you have a over b divided by c over d, then if you try to switch from division to product, then you have to flip this one. Instead of c over d, it will be d over c. What is your h? H divided by 1. H over 1, which is h. So if I flip this, it will be 1 over h. 1 over h. Now h cancel, 1h cancel with h. So you have 1, but negative sign here. There is negative sign. Negative 1 over 1 plus h. Now replace h by 0, guys. You are done. So this one, you have one question in the final exam. How to find, use the definition of the derivative to do it numerically. Use the definition of the derivative to do it algebraically. So this one here, this lecture here, that is what you have for this one. If you have any question, please come to my office. Thank you.